Why settle for ordinary lessons? Discover a smarter, easier way to learn. This is Muto Online. Get instant access to notes, past papers, and scenario-solved lessons, all tailored to competence-based curriculum.
In the previous videos, we covered the oxidation, we covered the reduction, we introduced the topic, we gave the key terms, we saw how to calculate for the oxidation states, we defined the oxidation states, we even looked at the principles we follow when calculating oxidation states and numbers. We also looked at the applications of the redox and the reduction reactions. For today, I'm here to take you through two things. That is majorly to look at more about redox reactions, as well as looking at the oxidizing and reducing agents. I'm purposely here to take you through these two. To cut the story short, we last time defined what a redox reaction is. We defined it and we said that it is any reaction where oxidation and reduction reactions occur simultaneously within the same reaction. It is that reaction that consists of both oxidation and reduction reactions taking place simultaneously. I want us to use sample equations to come up with, for us to understand this better. I will start by giving a simple reaction. That is a reaction between sodium with chlorine, simply giving us sodium chloride. When you look at this reaction, it is a simple reaction, but it is explaining. When we look at it, in this reaction, we are going to find that the sodium is losing electrons as the electrons are gained by this chlorine. And since the sodium is losing the electrons, remember the definition of oxidation as the loss of electrons. It means that this sodium is oxidized in that direction as the chlorine is reduced. Since there is exchange of electrons, and we can see that still there is also change in oxidation states. Here, sodium has an oxidation state of 0. And the chlorine also has an oxidation state of 0. When we calculate for this oxidation state of this one, we shall find that the sodium in this compound formed has an oxidation state of +1. We are seeing the oxidation state is increasing of sodium. And that of chlorine, we shall find that it has an oxidation state of -1, as this one is reducing from 0 to negative, from 0 to +1. So in this reaction, there is both oxidation and reduction occurring at the same time, occurring simultaneously. So we've explained oxidation and reduction in two directions, in terms of oxidation states and in terms of loss or gain of electrons. I think we've explained this, and we can see it.
All right, picture this. You're charging your phone, riding your bike, or even just breathing. What do all these things have in common? Redox reactions. I know, sounds like a mouthful, but stick with me. This is where chemistry gets seriously cool. Let's break it down. Redox is just short for reduction oxidation. It's basically when one substance loses electrons and another one gains them. It's like the ultimate game of pass the parcel, but with tiny invisible particles. Here's where it gets wild. Every battery, every fire, even rust on your bike, it's all redox in action. When your phone's battery powers up, electrons are moving from one material to another, releasing energy you use to text your friends or scroll TikTok. That's redox making your life easier. And hey, it's not just tech. Every time you breathe, your body's doing redox, swapping oxygen and carbon dioxide to keep you alive. Even plants rely on redox to turn sunlight into food through photosynthesis.
And we can see it.
So yeah, redox is pretty much
We
everywhere,
can also look
making
at
life,
a reaction where zinc powder is added to a solution of copper 2 sulfate. This reaction will involve zinc displacing copper from its solution, giving us copper solids, which will appear as residues in the solution, and zinc sulfate. So this is also a redox reaction for a reason. We are going to find that this zinc in this time, in this place, it has an oxidation state of 0. It has an oxidation state as 0. Remember, we said that the elements in uncombined states have oxidation states of 0. And we are seeing in this reaction, copper is, we can calculate for its oxidation state. We shall look at it. But here it is 0. We can calculate for the oxidation state of this. Let's say it is X plus that of sulfur, which is a 3, and negative 3, plus of that of oxygen, which is a negative 2 times a 4, giving us a 0, plus X, X will be a negative 3, plus a negative 8, giving us a 0, giving us our X as 0 plus this is 11, giving us an oxidation state of positive 11 in this compound, copper 2 sulfate. Copper has this oxidation state. It is decreasing from whatever the value is to a 0. And we looked at oxidation, the reduction, as a decrease in oxidation state. So this means in this reaction, the zinc is giving out electrons accepted by this, such that this one is, this copper in this compound is reduced to copper. The copper 2 ions here, we can as well write this equation like this. We are finding it that in this reaction, the zinc or the zinc powder is reduced, is oxidized. Since we are looking at its oxidation state is increasing from 0 to a positive 2. And we are seeing that of copper, it is decreasing from a positive 2 to a 0. So this means that zinc, since there is an increase in oxidation state of zinc, zinc is being oxidized as copper is reduced. Why is it reduced? Because we are seeing its oxidation state is decreasing from a positive 2 to a 0. So this implies that that is an oxidation, a redox reaction, because it is involving both reduction and oxidation occurring simultaneously. You can have more examples. Let's say hydrogen. When burnt in air, it always forms molecules of water. At this point, the hydrogen has an oxidation state of 0 as well as oxygen. But which is not the case here. Here the hydrogen has an oxidation of, let's say, let us call it 2x plus a negative 2, giving us a 0. Let's have a look at its oxidation state. At 2x, giving us, the hydrogen has an oxidation state of positive 2, of positive 1. The hydrogen has an oxidation state of positive 1. Yet this side it had a 0. So there is an increase in oxidation state of hydrogen. So for this it is 1, and for this one it is a negative 2. There is a decrease in the oxidation state of oxygen and an increase in the oxidation state of hydrogen. So in this reaction, in that direction, hydrogen is oxidized to water as oxygen is reduced to water. Still, we can look at it in terms of addition or removal of oxygen or hydrogen. To hydrogen has been added oxygen so that it becomes water. So in that direction, the hydrogen is oxidized since on it has been added oxygen. And the oxygen is reduced since on it has been added hydrogen. So this can also be a redox reaction because both oxidation and reduction are occurring simultaneously. There are many examples, we cannot finish them. We can talk of the process of rusting, where iron is reacted with moist air. We can still explain oxidation in this case as in terms of oxidation states and in terms of addition or removal of hydrogen or oxygen. In this reaction, we are going to find that this oxygen has been reduced. Why? We are saying on it has been added hydrogen to form an hydroxide ion. So it is a reduction in that direction. The iron is being oxidized. Why? We are seeing in this side, it has an oxidation state of 0. And this side, we are going to find that there is an increase in the oxidation state of the iron. And I would like you in the comment section to explain for me this reaction as a redox reaction in terms of oxidation numbers of iron and oxygen in that reaction. Please put the answers in the comment section so that we can judge whether you've picked something. Please explain it in terms of oxidation numbers of iron and oxygen as reactants and as products. I would like to see that as my judgment of whether I've taught or not.
Why settle for ordinary lessons? Discover a smarter, easier way to learn. This is Muto Online. Get instant access to notes, past papers, and scenario-solved lessons, all tailored as a competence-based curriculum.
Whether it's UNEB prep or just extra practice, we're here to make learning fun and easy. Subscribe now and let's ace those exams together.